Go to the second topic, which is thermal expansion. So we know that material expand when we raise temperature. So let's say I take this rod of length L and at temperature T. When I raise temperature with delta T, I will increase the length by L plus delta L. That's by how much this rod expand. Well, we can see that this expansion will depend on delta T, by how much I raise the temperature. So this should be proportional to delta T. It should be proportional to the initial length of the rod. Why is that? Let's say you have a 1 meter rod, a 1 meter rod. It will expand by 1 millimeter. And you take another 1 meter rod. It will expand by the same amount, 1 millimeter. If you take a 2 meter rod, well, it will expand by twice expansion, 2 millimeter. So the expansion depends on the initial length, right? And there is another parameter here, alpha, which we call coefficient of linear expansion. Okay, simple as that. Volume expansion. Here we talk about linear expansion, so we are seeing how the lengths change. If we are interested on volume expansion, because this rod will not change just in length, it will change in all directions. So the volume also will increase. How the volume increase? We use the same equation pretty much, delta V. So during an increment of delta T, delta temperature, the volume will expand by delta V. It starts from the initial volume, and there is a coefficient here, beta. So it turned out that beta is approximatively equal to 3 alpha, especially for solid. It works very well, this approximation. The table showing the alpha for some substance. Most important stuff here is that alpha, the order of magnitude of alpha, that's 10 to the power minus 6. What is the unit? Per degree Celsius or per Kelvin. Okay, so per degree Celsius. All right, because alpha, what is it? If you want a unit of alpha, that's unit, that's meter, that's degree Celsius, so that's 1 over degree Celsius, right? Let's see a checkpoint now. This checkpoint. 4 rectangular metal plates with side L, 2L, and 3L. So these are rectangular plates. They have side L, 2L, and 3L. It's easy to recognize where is L. Basically, that's L, that's L, that's L. And 2L, what is it? This one, and this one, and this one. This is 2L. And 3L, basically, is this height here, is this length here. Okay. They are all made from same material, so they have same alpha. You don't need to care about that. And their temperature is to be increased by the same amount, so delta T is the same. Rank plates according to the expected increase in their vertical height, and in their area greatest first. So let's talk about vertical height. So first question, I need to rank the expansion according to the vertical height, the vertical expansion. Okay, so here what we have, linear expansion. Although we have an area here, but we are interested first in the linear expansion of the vertical height. L equal alpha, delta L, sorry, equal alpha L delta T. But it states the text that delta T is constant, alpha is constant. So what is changing here, the initial length. Initial length. So ranking the situation according to the vertical height, it means ranking them according to what? Initial height. What is the initial height? That's 2L, 3L, 3L, and L. So ranking them greatest first, easy. 2 equal to 3, greater than 1, greater than 4. Done. So that's A. Let's go to B. Area expansion. Well, in the previous slide, I didn't show you the area expansion formula, but we can just deduce it from this. What do you think the area expansion formula will be? Well, that's delta A equal initial area, delta T, and a coefficient here that we can call gamma. Gamma it turned out to be 2 alpha. It's not important here. All what you need to know that the gamma is related to alpha, so is related to the same material. So if you have the same material, gamma is the same. Proportionality factor is the same. So the proportionality factor depends on which material we are talking about. Okay, so this is constant, this is constant. What is changing is the area. So the expansion, area expansion depends on the initial area. So we need to rank the initial area of the three, of the 4 situations. So we need just to calculate that. This is L, this is 2L. What is the initial area? 2L squared. Here, L and 3L, that's 3L squared. 2L and 3L, that's 6L squared. And we have 2L and L, that's 2L squared. And here we can rank the area easily. We have 3 greater than 2 greater than 1 equal 4. Right? As easy as that.